Now in third example we will discuss a very interesting example, that is inverse interpolation. Inverse interpolation. What is inverse interpolation? You see, in interpolation, what we do is when a set of data x and y is given, for given x we find y. But in inverse interpolation, the problem is different. We will be given a set of data, but for a given y we have to calculate x. Okay, that is inverse interpolation. How we do it? We will start from an example. Say the set of data is, this is x, this is y. Okay, a set of data is given, that is x is 1, 2, 4 and 7, and for 1 the value of y is 3, for 2 the value of y is 8, for 4 the value of y is 20, for 7 the value of y is 35. So this is the given data. Now question is, we have to find the value of x when y is will be given, when y will be given. Okay, suppose say find x for y is equal to something. So the value of y should lie between 3 to 35. Say y is equal to 15. Okay, so that is why this problem is called as inverse interpolation, because normally we will be given a set of data, for a given x we find y, but here for a given y we calculate x, right? So as for given y we calculate x, just you reverse the order of data x and y. Normally what happens when we consider x as the independent data or the first column and y we consider in the second column, but here we will consider in a reverse manner. Solution: first you write y, the first column, next column you write x. What is y? Y is 3, 8, 20, 35. What is x? 1, 2, 4, 7. Right. So this, for the time being we consider y is independent variable and x is dependent variable, and this set of data is given. Then we have to find out the divided difference interpolation. In previous case we denote x0, x1. What is x0, x1? x0, x1 is the first column data. Similarly here, as it is inverse interpolation, we will consider y0, y1. Clear? Because y is the first data. Okay, but how we will calculate? The data of x will be, the difference of data of x will be in the numerator and this will be in the denominator, that is 2 minus 1 by 8 minus 3. Okay, so what is the result? That is 0.2. Similarly 4 minus 2 by 20 minus 8, that is 0.166, and for this data 7 minus 4 by 35 minus 20, the result is 0.6. Next we calculate the second order, that is y0, y1 and y2, second order divided difference. For second order divided difference, this data 0.166 minus 0.2 divided by 20 minus 3. The result will be minus 0.00196. Then for this one, the second order divided difference, this is 0.6 minus 0.166 by 35 minus 8. Okay, so that is 0.0160. This is our second order divided difference. Then third order, y0, y1, y2, y3. This is the third order divided difference. For this case, we write this data 0.0160 minus of a minus 0.00196 divided by this 35 minus 3. What it will give? It will give us 0.00056. So this is our divided difference table. Okay. Now we have to calculate the value of x for y. That means if y is 15, that means in this place 15, then what is the value of here? In the previous example, we were writing the functions as y of x, but here we will write x of y, means input will be y and we have to find out x of y, that equal to. Previous formula kon likhthile, we were writing in the previous formula y0, but here we will write x0 plus. In previous formula we are writing x minus x0, here we will write y minus y0 into this y0 y1 plus y minus y0 into y minus y1 y0 y1 y2 plus y minus y0 into y minus y1 into y minus y2 into y0 y1 y2 y3. Now just we put the values, that is x of y. What is y? Y is 15, that equal to x0 is 1, this is x0, that is 1 plus y minus y0, that is 15 minus y0, that is 3 into first order divided difference, this is 0.2 plus y minus y0, y is 15, y0 is 3 into 15 minus y1 is 8 into second order divided difference, that is minus 0.000196, then plus y minus y0, that is 15 minus 3 into 15 minus 8 into 15 minus 20 into the third order, that is 0.00056. Okay, so if we calculate all this using a calculator, we will get the result 3.00016. That means when the value of y is 15, corresponding to that the value of x will be 3.0016. okay, that means for x is equal to 3.00016, we get y is equal to 15. So this is the inverse interpolation. Now we will consider a very interesting problem, that is solution of one equation by using Newton's divided difference interpolation, right? It is why it is interesting. In your previous class, you know two methods. One is the second method by which you solve equation. Another one is the Newton-Raphson method by which you solve equations. But now it is interesting that by using interpolation techniques, we can also solve one equations, which is a very exceptional example. Let us see the beauty of this problem. Okay. So I am considering one example, that solve x cube minus x minus 1 equal to 0 by Newton's divided difference interpolation. Right, so this is the problem. You see how we solve it. Okay, the technique is, for this case, what is fx? Solution. In first step 1, we decide fx. What is fx? Fx is x cube minus x minus 1. Okay. Then we have to find the solution. What is the meaning of a solution? The meaning of solution is, we will find certain value of x by any methods, by any techniques. We will find a value of x. If we put the value of x here, it will be nearly 0. Then that x will be called as the approximate solutions. That is our idea. That means if this is fx, we will find the value of x for which it will be 0. So now we make a table. So under what technique we make a table, you see. This is step 2. So this is x and this is y or fx, and fx is this polynomial. Okay, so how we decide this x? We decide x as 1, 1.1, 1.2, 1.3. Okay, and for 1 the value of fx is minus 1. For 1.1 it is minus 0.769. For 1.2 it is minus 0.472. For 1.3 it is 0.897. Now you mark this fx. Actually fx should be 0. The value of fx is minus 1, minus 0 point something, minus 0.4, 0.89. That means these values are very close to 0. This is 0.8, this is 0.4. It may be positive or negative, right? That means if we say f of x is 0, 0 means it lies within it, because this is minus 0.4, this is plus 0.8, so 0 will be here, right? So question is, if 0 is here, what is the corresponding value here? And if we find these values, okay, so 0 is here, then what is the corresponding value here? So if we are able to find this one, that is the purpose, that is the value of x, means for that x fx is 0, and this is nothing but a inverse interpolation techniques. Okay, so now we will consider, so once we make this table, then we will change the order of the table. We will consider this table as our first column and this table as our second column. Okay, so let us rewrite the table as this as first and this as second. Step 3. Step 3. In step 3 you write first is y, then x. Okay, the value of y is minus 1, then minus 0.769, minus 0.472 and 0.897. This is 1, 1.1, 1.2, 1.3. Okay, because it is the inverse interpolation. Then you find first order divided difference, that is y0, y1, means this data minus this data by this data minus this data, that gives us 0.43290. Similarly 1.2 minus 1.1 divided by minus 0.472 minus 0.769, and after the calculation it gives 0.336700. Then for this data 1.3 minus 1.2 by 0.897 minus of 0.472, the result it gives 0.073046. So this is our first order divided difference. Then you find second order divided difference, that is y0, y1, y2, means 0.33670 minus 0.43290 divided by minus 0.472 minus 1. The result will give us minus 0.182197. Then 0.073046 minus 0.33670 divided by 0.897 minus 0.769. The result will get 0.158256. Then the third order y0, y1, y2, y3, that is this data 0.158256 minus of minus 0.182197 divided by 0.897 minus of minus 1. The result it gives 0.01262. Now we find the divided difference table. Okay, so we have to find when this is 0, what is this? Okay, so this is our requirement. That means you have to find x of 0. X of 0. What is the formula? x sub 0 means that is x0 plus y minus y0 first order y0 y1 plus y minus y0 into y minus y1 into second order y0 y1 y2 plus y minus y0 into y minus y1 into y minus y2 into third order, that is y0 y1 y2 y3. Then you put the values. What is x0? x0 is 1. Y minus y0, y0 is y is 0, y0 is minus 1 into y0 y1, that is 0.43290. Then come to this plus y minus y0, y is 0, y0 is minus of minus 1, y is 0, y1 is minus of 0.769 into second order, that is minus 0.182197. Then plus this one 0 minus of minus 1 into 0 minus of y1 is minus 0.769 into 0.0 minus third minus 0.472 into the third order, that is 0.01262. Now you calculate by using the calculator. We will get the result as 1.2973. Okay, that means for x is equal to 1.2973, fx is nearly equal to 0. That implies x is equal to 1.2973 is the approximate solution for this equation. Okay, you see how interesting and beautiful problem this is, that we are solving the equations not using secant, not using Newton option, but we are using Newton's divided difference. Okay, thank you.